Okay, so I don't think I was done. I thought I was only had this one slide left, but I realized that I didn't. And I think I was just talking about reflection, and so I wanted to just kind of go back over. Reflection is when we interact with, like, say, a barrier, and again, when we reflect back on the opposite side. And so that's kind of how we see it in reflection. And we'll probably see this in the wave demonstrations of the Slinkies. So again, reflection hits the wall, bounces back on the other side. We also get kind of some wave interaction when we start to look at changing from one medium to another. So maybe I have like a wave that's traveling through, and then I have like this big heavy string on the other side. Now what happens is that we have maybe like a less dense material and a more dense material. Now again, it's about transfer of energy. So it's kind of like a momentum almost, in a sense, that some of the momentum of that, or some of the energy of that wave, is going to transfer into our new medium, and then some of it is actually going to reflect back. So what we may see in this situation is we may see a slight reflection back as our bigger medium carries forward. Okay, so again, the sum of our two energies would be equal. So again, it's conservation of energy. The reverse would be true if we actually saw, like, going from a more dense medium into a less dense medium. We might actually see a little slightly bigger amplitude change, because, or not bigger amplitude, but we would see a change in our frequency or a change in our period due to the fact that that energy is going to transfer through. Okay, so again, reflections happen whenever we change mediums, or if we sometimes have barriers like that. The last thing, now this is again the last thing that I wanted to talk about, was a thing called a standing wave. And we can create standing waves quite easily with the Slinkies. And so what we're doing is we're essentially matching it, so that as we hit a barrier on the one side, okay, the wave coming up and the wave coming down kind of match at the same point. And so what we see is we see something that looks like this. Okay, where here's our wave, and then we get the corresponding pattern this way. And we see that we get this kind of thing, and we like to call this a standing wave. It's like what happens with a guitar string or a piano string as it's vibrating. Forms this wave pattern. And we get these things called nodes and antinodes. Now a node is a point of no movement. So it looks like the wave is not moving at that point. So in my little picture that I drew there, I've got 1, 2, 3, 4, 5 nodes, 5 nodes. Now an antinode then represents the points at where we have maximum displacement, okay? No displacement versus maximum displacement. And in this sense, we can start to look at strings, okay? And that's kind of our big thing. And if I have a string, I can pluck the string, and I can actually get a standing wave that looks like this, okay? This is the most basic standing wave for any string. Okay, so if this is my length of my string, I can look at this and I say, well, that's a standing wave. And it's vibrating back and forth, and I have 2 nodes and 1 antinode. We usually tend to look at what part of a wave is fitting inside of this standing wave. Crest, and this would represent a trough, and so if I started at this point, I'd end at this point. This would represent like 1 wavelength. Okay. Now in this pattern, I'm actually only getting like half of a wavelength, okay? I'm only getting half of a wavelength. So this length in this picture is half of a wavelength. If I wanted to look at this and say, well, what would it look like if I had a full wavelength? Okay, this length, so I'm going to keep the same kind of length, general length here, and I'd pluck it, and it would form something like this. Okay? And I get a node, and I get a node, and I get a node. So I have 3 nodes, 2 antinodes, and that would give me 1 full wave in this length. So in this picture in particular, this length is equal to now 1 wavelength. And we start to look at this anytime that we look at musical instruments, and we're going to get into this even more when we start talking about sounds and how sound vibrates inside of like tubes. and you'll see something like this. We'll have a similar thing to a standing wave inside of a tube of an air column, and we'll then talk also about nodes and antinodes, except there'll be forms of high pressures and low pressures. All right, so that was the short end of this one, and so now you just had about 2 videos. We came up to just a little over 20 minutes. So, and questions, we'll see tomorrow, and we'll probably have some cool little demonstrations to go along with our problem set tomorrow.